Theo. We got Josh. Samuel.
Yeah.
Ella. Nope. Sonia. Andrew should not be here. Nathan is here. Katie not. Nicholas is. Taz is here. Gleb is here. Max is here. Ashley's here. Neha is not. And just walking in is late is Lavina. Okay, we got that going. Okay, no, except if you have notes that you do on the computer, download the PDF. It is should already be there from last day. I have a new set. New set? You say no thing? Oh, I thought you said O thing. New set? New set. New set? Are you doing an iPad? You download PDF? New set? Put show away. What are you doing? Put it down. What show? No.
Wait, is it N?
Pardon?
N?
N?
Is the thing N?
It's N, yes.
Are our quizzes out yet?
No, I haven't even marked them yet. I'm hoping to have that done by Monday.
Okay.
Do we have class Monday? We should.
Yeah, we do.
Okay.
It's not loaded.
Pardon?
It says something. Please come to
It should be there.
Yeah, we asked.
PLON, we've actually done quite a bit of it. It just reemphasizes how we write equations, and given the number of people who've said, when do you put in water? This will help just reinforce that. So that's a question you've had. This should help you out with that. Also, this is essentially the anniversary. We're about in the right date. 2019 is when humans first took a picture of a black hole. A huge amount of data, 5 petabytes necessary to do that. And the original picture reported of when they had the data in and they realized they were successful. That was really cool. So we are here from Arrhenius. So this is the first one you did. In grades 10, finish this reaction. HA plus BOH. And then let's do it underneath. HNO3 plus CaOH2.
Is that COH, OH2 or CA?
A. And let's, I'll ask someone randomly. Won't make you do this at the board. Just use my app. Nope, I don't want that one. We are F4. I don't want to put that down. What am I doing? I'm going to be a little pedantic about it. I want you to be fairly What type of arrow? What's on the other side? And then balance. Nick, what type of arrow?
Single arrow.
Single arrow. How do you know?
It's a full reaction.
Pardon?
It does like 100%.
Does 100%. Now, I told you it was a strong acid, but even if you didn't, anything where you see this is going to be a strong base. We're not going to give you solubility equations where you have to worry about that. So if you see a hydroxide salt, very much likely you got a strong base. So Arrhenius, we always did strong acid plus strong base, and then continue. What else do you get?
H2O and BA.
H2O plus BA. Acid plus base gives us salt plus water. One of the areas, in terms of when people are making equations on the last quiz, one thing I noticed is some people did some really good, like really good, ice tables and KAs. But there was no ice tables and KAs in the quiz because they didn't cover those learning outcomes. And so it was a much simpler problem than you were looking for. Still recognizing that these older reactions that you learned earlier still exist. There are still one-way arrows, and you need to be able to tell them apart. We'll probably do that practice on our next quiz. Next one, Gleb.
H2O
H2O,
and
CaNO3. All good? There is a slight error. CaNO3 too. So don't forget your charges and your bracketing. Keep that all together. And then what do we have to do?
2H2O and 2HNO3.
Yeah, we need to balance. So get the balance. And then you have the ratios. Okay. From Arrhenius, these are salts. So a salt, from the Arrhenius equations, not Arrhenius equations, from Arrhenius acids and bases, a salt is a cation and anion from an acid-base reaction, which essentially means all salts, because you can take any anion and put a hydrogen in front of it, and now you've got an acid. You can take any metal, put hydroxide on it, now you have a base. So any ionic compound is technically a salt, if you really want it to be. Table salt is just the most famous kind, coming as it does from hydrochloric acid and sodium hydroxide.
What's after acid?
What's after acid?
Yeah, when you wrote
Oh, acid base.
acid base.
That got a little messy. So I've got a couple others I want you to do here. So how does this relate? Now, these ones, relatively okay. Let's do SrOH2 plus H2SO4. Assume you have enough of everything. Predict the product. And balance. Taz.
H2O.
What kind of arrow?
Equilibrium. Straight.
Straight. The reason it's straight, well, I did the pause. That might have given you a hint. If you see a hydroxide there, it's always going to be straight. This is also a strong acid, but even more importantly, That is a strong base, so it will react with every scrap of hydrogen that it can. So we get H2O plus, what's our salt? That's our SO4. Now, this reaction here, these salts are neutral. And Taz, headphones out? Or I believe you're going to be watching, what was the sitcom again?
No.
Well, you could be listening to it.
What's the point?
'Cause-
I can't watch it. It's a podcast.
I don't know what the point is. I have long given up wondering why people do things. I've been a house parent for a very long time.
Look at the other H.
Excellent question. What happened to the other H?
Does it do
H2O.
double
Dissolve?
So we haven't balanced yet. So what do we need?
2 and 5.
2 in front of the H2O.
So you just don't care about it?
Don't care about who? Oh, I know what you're doing.
Because like,
Because you're doing this, right? So you're like, it reacted with the first hydrogen, right?
yeah.
But will those react?
No.
What's this?
Like what's his name?
Oh, not well. That would help too. Yeah, either way, or just like what class? Acid, base, strong, weak.
Base.
Base. So it's a base. And given that it has a hydroxide, what kind of base?
Strong.
It's a strong base. So it will react with every hydrogen it can get. So it's going to take that one off, and you're going to get SO4 minus 2.
Okay.
So if you have a strong base involved, it will react with every hydrogen available, even if they're weak. So when we were doing just what do they do in water, we were showing that, one of them came off. But if it's reacting with something, it will react with both of them. So the first one is from a strong acid, but the second one is from a weak acid. But since it's a strong base, it's going to react with both of them. Now that being said, if you reacted just enough to react with all of the sulfuric acid and all of the strontium hydroxide, so all of it is gone, and the only thing you have as products, is this going to be acidic, basic, or neutral?
Neutral.
Pardon?
Neutral.
Why?
Because there's just water and salt.
There's just water and salt. So the water won't do anything, and no part of the salt will do anything. Can you prove that? You probably can. Everybody take out your data table. Take out your data table. Turn to the section on acids and bases. Do I have one here? Yeah, turn to this page. I want you to find strontium plus 2, because we have strontium sulfate. And I want you to find sulfate. Are they on there anywhere? Which one?
I found sulfate base.
Hydrogen sulfate ion.
There's a hydrogen sulfate ion, but that's not part of the HSRSO4, but the sulfate definitely is, so we got that one. Do we have it anywhere else? Gleb?
Do you have any more data tables?
Yeah, come on up. How many do you want?
Just one.
Oh, so please.
Oh, you also, okay, there you go. There's always some, or, don't you want it? Okay. What does this mean if we have something on this side of the table?
Base.
It's a base. So if we go back to here, where was I? I was here. Will this be acidic, basic, or neutral?
Base.
It'll be basic. Because SO4 minus 2 is now left over and actually does something. It is in there, it's a weak base. So next task. Show me what it does. Write out the reaction. And from Nick.
What are we doing?
What reaction does that do if you have it in water as an acid-base reaction?
HSO4.
No, there is no HSO4 left. You only have these two things left. There's only water in a solution, so that's, who cares? And now we have strontium sulfate, of which only one of them we could find on the table, the sulfate. Ooh, this, well, I'll do that afterwards, but maybe I'll put it down below. The first thing that's going to happen is if you made this strontium sulfate, what does it do? It dissociates. So you write a dissociation equation. If it's soluble, it's a one-way arrow. If it's low solubility, you get a two-way arrow. We'll assume it's soluble. Is it soluble? Don't know if I picked a good one. But let's just pretend it is regardless. AQ, dissociation equation.
It's not soluble.
Okay, we are going to pretend it is, but that's good to know. Now, what kind of ion is strontium in this, if it was 100% soluble? It's 2 plus.
What is 100%?
And if it doesn't react with anything in the water, what do we call the ions that don't react? We call them the same thing we call people who show up to sporting events but don't play. Yeah, spectator ions. Useless things. I think most sporting events would be more fun if the spectators could take part. Regatta's coming. High-powered paintball guns exist. So much more entertaining. Get a little bit more Hunger Games where you could, like, athletes only get to drink if you, like, send them water or something. And then we'd figure out that this is a base. When you have a base in water, what does it react with? H2O.
OH.
Yeah. Plus H2O. What do you then get?
OH and HSO4.
OH minus plus HSO4. Yeah. This is what this learning outcome is, KBAT N. This is known as a hydrolysis equation or hydrolysis reaction. You're taking water, you're splitting it apart with the ion. Hydrolysis. Those of you in biology, what does lysis mean? I don't know if you do that. The process of lysis? To break down? No? Okay, never mind. You don't do biochemistry, lytic reactions, lysis, splitting? Sad. Everybody got that? Who needs it? Given how many people are away, what I'm going to ask is I have KCN. I want you to show me the dissociation equation. And then the hydrolysis equation of the part that will react. Not both parts always do. So just for the salt that reacts, like the ion. Show me both of those. The rest of the time you can work on Hebden. Because then I'll come back here next day and we'll show both of those to everybody else who is away. So that seems like we'll have no advantage having all these systems. So just show me both of those when you're done, and then you can pull out your Hebden, start working on it. Pardon? What's the theme of Alex Arthur? I was in assembly.
Skipping us up.
I actually was talking to a student, and then we both realized we were missing assembly.
Who was it?
We started it because it was in science and ethics, and he wanted to know, he's buying a new shotgun with his dad, and he wanted to know if he could set up a trap for like burglars. And I was trying to convince him how illegal and dangerous that is. Because so even in the U.S., where gun laws are a little bit more lax, that is illegal.
So, but what is CM? Minus.
Oh,
It's 1 minus.
cyanide. It's your table of polyatomic ions. Well, you know it's with K. What is potassium soluble with? Everything. So even if you don't know the solubility of CN or anything, you know it's going to be soluble with that. And so you have that left.
Yeah. That's it.
So just the dissociation equation, and then the hydrolysis equation. Just the two, bar, and then that's not the hydrolysis equation yet. The hydrolysis takes just the ion you need. So you don't use the whole KCN for that.
Oh, so you just.
So get rid of the spectators for the, because like this thing doesn't exist. HKCN is.
I thought it was KOH plus H.
It would be, yeah, but for the hydrolysis, we wouldn't keep in the spectator. So the purpose is you do the dissociation, get rid of the spectator, and then, because you might have to do two, because if both ions react, then you'd have two hydrolysis.
So that'd be more right. I'm just trying to find the charge on.
So that's the dissociation. What's the charge?
Oh, there it is.
Wait, there, no, yeah, it is. What's the charge in K?
Plus.
All row.
Dissociation.
Then the
But
hydrolysis.
doesn't
Dissociation
also
is
have to
after
K? KCN plus
No,
KO.
so you
No, because then you take that, and it's reacting in water,
And you go.
and at CN, you need a charge.
Oh.
There you go.
Oh.
So that comes up, CN minus, there's that, you get that, and then what's this charge? You have, right, and you have a plus on it.
Oh, I don't know how that got there.
Oh, okay. Do the dissociation first, and then the hydrolysis. And you have written the acid-base equation
Should we
for
just go for
ACN,
early lunch?
the hydrolysis equation. So you want to do the dissociation of KCN? And does the dissociation, if you look back at the previous one, does it have any plus H2Os?
Nope.
So I did?
No.
No, it doesn't. So the only one that has plus H2Os are the hydrolysis.
Okay.
The one where we're actually adding water and then we're seeing water split into OH minus and H.
Well, how do you know which?
Yeah.
Are all the acid-base reactions hydrolysis reactions?
You don't, if you do, yes. With an acid, you can go plus H2O and the H3O plus. You can also write it in a way that looks like a dissociation because it's just like H and thing goes to H plus and thing minus. But because they're just separating, you don't have to do it that way. But every base reaction has to be a hydrolysis reaction.
I was also wondering, can we go for early lunch?
Oh, you asked. That was sad. Because you can't go if you ask.
No.
Why not?
That's a rule. That's always been a rule.
Since when?
Since always, since teachers
No,
don't
please,
like
'cause we have
being
to
asked
meet
30
Saturday,
times.
the line gets like twice the size.
But what, there's no, it's just,
Wait, what
it's
do you
just,
want me to do?
it's just,
And all that chicken, all the protein's gonna be gone. You don't get there.
oh, first do the dissociation.
Oh,
So the KCN, so for the dissociation, same thing as Sonia, you just separate it. And then pick the one that's going to react as either an acid or a base, and then do it like this.
so
So I did it backwards. Do that one first, and then do that one
KCN,
second.
which is K, and it's
Yeah, it should be, you're making it more complicated than it needs to be. Da, da, da. Yes. And you do the thing on top, and then you do this
Wait, you added water.
They're done.
You add KCN to water.
No, why would you do that? It's just a, there, you have dissociation. Now, which one of those is going to react?
With water.
Yeah. A simple way to figure out this out now is which one is going to be on here.
CN.
Yeah.
So this one's gonna react.
So you don't include the spectator.
Oh, okay, got it. So it's like that.
Yeah, there you go. I don't know how I feel about you being able to have things like that. It makes it too easy. But now your charges.
Mr. Eagle?
Coming. You have yours. Yep, there we go. And then see if the two. Yep. Don't do that.
Sorry, I just love chemistry.
Let's go. Perfect. Yep. And then that one to there. Yep. So unlike grade 10, where we said an acid plus base goes to salt plus water and it's neutral afterwards, that's only true for strong acids and strong bases. If there's any portion of a weak acid or weak base on the other side, you will create a hydrolysis reaction that will affect the pH. And that is this entire section of. Who have I not checked? Excellent. Excellent. And get over. Okay, work time.
Mr. Neufeld,
Yep.
do you have any extra peptins that aren't writing on,
Extra headings that what?
that are empty?
Oh, you mean those spiral ones?
Yeah.
You just go to the store and buy one.
Oh, okay.
I give everyone it at the beginning of the year, but the expectation is after that you just get your own. That's just to make sure everybody starts off well. And now we're set up for that.